na magsigig gadako ang overhead sa usa ka router. Okay? Dako ang resources nga magamit niya. Gamit siyang CPU, gamit siyang memory, gamit siyang bandwidth. So those are the things nga gabugat ang network kay because the protocol that we are using is not that very good. Kung kabantay mo, ang iyahang administrative distance is equal to 120. So mas bugat siya. Whereas kung gagamit kag OSPF, ang imong administrative distance is only 110, right? And good to say for us nga naatay EIGRP. And EIGRP is also a link state type of protocol, which ang iyahang administrative distance is 90 lang. But unfortunately, not all routers has EIGRP. So there are pros and cons when using this type of protocol. Okay? So to further. So klaro naman kaayo sa ato nga when we perform already a neighbor, then that neighbor will be one electing a DR and BDR in order for it to send their information so that it cannot burden the other routers of sending the same information all over and over again. So, ang pinakalas ana is how do OSPF computes for the best route. So basically, when OSPF compute for the best route, the way the router choose the best route is using the metric called cost. So kinahanglan na adyo tay cost. Correct? And you know the cost already of each type of protocol. Like for example, the RIP, we have to identify the number of hops, right? When we are using the what we call the CIGRP, we are using the bandwidth and the delay. So those are the costs. But in the OSPF, we are computing the cost in terms of bandwidth. So in terms of bandwidth, let me pull up that slide. Kung saan siya ang gitawag nato na protocol. So concepts here. So if we are going to compute for the cost of that particular SPF, mano siya ang idea ana, no? The cost of a calculation, let's say for example, that would be the reference bandwidth divided by the interface bandwidth. So the default reference bandwidth is 100,000 kbps. Okay? So this is 100,000 kbps and the interface bandwidth that you are using. Okay? So sa interface, kamantay mo in G00 and is E00, so on and so forth, serial and gigabit interface. Okay? So always remember that when we compute it, we compute according to this one. So reference bandwidth, interface bandwidth, default reference bandwidth is this one. Then the interface bandwidth is this one. So if we are using a serial interface, that is 1.55 kbps. So when you use 1.55 kbps divided 100,000 divided by this one, that is 64. So the cost of using a serial connection is 64. Okay? And the cost of using an Ethernet is katong karaan pa kaayo nga mga kuan ano, katong the 10 Mbps pa na mga tawagan ni ng mga technology. So pasabutan na, that would be 100,000 divided by 10,000, that would be 10. And if you are using a fast Ethernet, in which karon mga bag-o na ni karon, di ba? Kabantay mo is fast Ethernet is 100 kbps or 100 mbps. This one is 100,000 kbps, therefore divided by 100,000 kbps, that's 1. So the cost of using a fast Ethernet is 1. Much more if you are using gigabit Ethernet. So the answer will always be 1. So any number greater than 100,000 kbps divided by the interface bandwidth, that will always be 1. Okay? Sige. So I hope nakuha na tong idea. Now let's try to give example here. So let's say for example there are 192.168.0.0 would like to go to 10.0.0.0 here. So there are 3 ways to do that. So it can go R1, R4, R3, then go to 10.0.0.0, or R1, R2, R3, then destination 10.0.0.0, or R1, R5, R3, 10.0.0.0. So we're going to compute each of the path. This is what we call the shortest path first. So whoever has the least number of items or least number of computation, the result for the cost, so that would be the best path. So let's say for example this is a serial connection from R1 to R4, then serial connection from R4 to R3. So 144 per kbps, that's 144 kbps, and that is 64, right? 64 plus 64 plus 10. Okay, 10 Mbps man ang Ethernet na to. You get the idea? Okay, good. So, kung 10 Mbps siya, ang mahitabuan ni is you are going to add 10, 64 plus 64 plus 10, that's 138. Okay? So, the second path is 10 that 10 that 10 plus 10 plus 10, that's 30 because that's 10 Mbps, 10 Mbps, and 10 Mbps, the destination is 10.0.0. Take note, nagagamit kita og, let's say for example, a crossover cable, pero Cat5 siya, dili siya Cat5e. So basically, gi-connect na to siya padulong ngadto, na kay 10 Mbps, 10 Mbps, then it reaches 10 Mbps, which is 30. Get the idea? Klaro. So, if I'm using a fast Ethernet cable from R1 to R3 via R5, so may tabuan that's 100 Mbps, right? That's equal to 1. The cost is 1. Then the cost of 100 Mbps is also 1, and the cost of 10 Mbps is 10. So if you're going to add all, that's 1 plus 1 plus 10, that's 12. So basically, we know already what's the best path. So this one is the best path, and this is the backup path, the R2. Okay? Because just in case lang, no? Upon the delivery pack, naputol siya. So meaning na pa siya backup route. Yeah, you get the idea. So best kaayo ang OSPF in this manner. Okay? So we know that R5 is the best path. Okay, so far, do you have any question with implementing OSPF? So I hope klaro kaayo on how OSPF is being implemented and why we implement it that way. Okay, so my next video will be implementing OSPF